So now let's have a look back on the historical development of pre-stressing. So long ago, so before, way back 1872, P.H. Jackson, an engineer from California, patented a pre-stressing system that used a tie rod to construct beams or arches from individual blocks. So what P.H. Jackson did is something like this. So imagine these are concrete blocks, and then P.H. Jackson tried to counteract the tendency uh, to fall of each of these concrete block by applying a compressive force using a tie rod that is originally pre-stressed. So you just imagine, if you want to imagine this system, imagine you have a series of books, and then you try to lift up those series of books by applying a compressive force using your hands on the extreme books. So it's those that system looks something similar to this, the one that Page Jackson patented. So he patented that system. He's the first one to first use that kind of system. And then after say 18 years after that, 16 years. After 16 years after that, uh, C.W. Doring, I don't know how to correctly pronounce the name. C.W. Doring of Germany obtained a patent for pre-stressing slabs with metal wires. So he's the first one to pre-stress slabs using metal wires. So he patented that system. Although take note, these early attempts in the development of pre-stressing are not actually successful. Why? Because on these early stages or early attempts on the development of pre-stressing, these people doesn't or don't recognize the fact that the compressive force, as you have seen a while ago, the compressive force exerted to the concrete by the pre-stressing reinforcement is not constant all throughout the lifespan of the pre-stressed concrete beam. The magnitude of that compressive force is not constant all throughout the lifespan of the pre-stressed concrete. It actually diminishes as time goes by. Therefore, uh, loss of pre-stress happens, meaning the magnitude of that force or the magnitude of the stress it induces uh, diminishes or decreases as time goes by. So that scenario of decreasing the magnitude of that pre-stress force or pre-stressing stress applied to the pre-stress concrete is what we call loss of pre-stress. So later on, as we go with our subject or our course, you will know more about loss of pre-stress. And then after that, uh, R.E. Deal of Alexandria, Nebraska, recognized the effect of the shrinkage and creep of concrete on the loss of pre-stress. He subsequently developed the idea that successive post-tensioning of unbonded rods would compensate for the time-dependent loss of stress in the rods due to the decrease in the length of the member because of creep and shrinkage. So creep or shrinkage looks something like this. Actually, this is shrinkage. So at this time, deal of R.E. Deal of Alexandria already recognized that there is what we call loss of pre-stress happening when you pre-stress a material. So he recognized that one of the reasons why the pre-stress uh, loses or diminishes its value or magnitude is because of the shrink and creep of concrete. So again, later on, as we go with our course, you will know more about the loss of pre-stress due to shrinkage and creep. And then after that, uh, on 1920s, W.H. Hewitt, I don't know again how to pronounce the surname correctly, of Minneapolis, yeah, whatever it's called, developed the principles of circular pre-stressing. He hoped stress horizontal reinforcement around walls of concrete tanks through the use of turnbuckles to prevent cracking due to internal liquid pressure, thereby achieving water tightness. So this person, however his surname is pronounced, this person is the pioneer in circular pre-stressing. So he's the first one to hoop stress horizontal reinforcement around the walls of the concrete tank using a turnbuckle. So turnbuckle is something na pinipihit. Actually, nakakita na kayo niyan ng turnbuckle. Usually, you can see that turnbuckle on the rods sa mga roofs ng mga gym, for example. And then, around 1926 to 1928, Eugene Freyssinet proposed methods to overcome pre-stress losses through the use of high strength and high ductility steels. Actually, Eugene Freyssinet is a famous name in pre-stressing, especially on post-tensioning. Actually, if I remember it correctly, he has a company which has a name. I don't know exactly the name. I think it's Freyssinet International. So I think they focuses on post tensioning activities or any other activities, but I'm sure it's about pre-stressing. It's more about pre-stressing. So you have to remember that name because that is a famous name in the pre-stressing industry. And then, come 1940, he introduced the now well-known and well-accepted Freyssinet system, comprising the conical wedge anchor for 12-wire tendons. So this is Freyssinet, Eugene Freyssinet, and this is the Freyssinet system we are talking about here. So this is the conical wedge anchor uh, for 12-wire tendons. So actually that is uh, related to the pre-stressing operations. So later on you will know more about that as we go on with our course. And then on the time of World War II, G. Magnel of Ghent, Belgium, and Y. Guyan of Paris extensively developed and used the concept of pre-stressing for the design and construction of numerous bridges in Western and Central Europe. Actually, again, Magnel, the name Magnel again is a famous name in pre-stressing because he proposed the now called Magnel system, which also use wedges to anchor the pre-stressing wires, just like what Freyssinet did on the Freyssinet system. They just differed uh, in that the Magnel system were flat in shape, unlike yung Freyssinet system, it's not flat in shape. The Magnel system is flat in shape, thereby accommodating the pre-stressing of two wires at a time. So remember the name Magnel and Magnel system. This is Magnel, G Magnel. Then after that, 1930s to 1960s, P.W. Abeles, I don't know how to pronounce the surname, of England introduced and developed the concept of partial pre-stressing. So when we say partial pre-stressing, it just means, in simple words, we are not fully pre-stressing the pre-stressing reinforcement. That's why it's called partial pre-stressing. We're not fully uh, applying pre-stress. We're not conducting full pre-stressing That's why it's called partial pre-stressing. So later on, you will understand more about that. So this is P.W. Abeles. And then F. Leonhard of Germany, V. Mikhailov of Russia, and T.Y. Lin of the United States also contributed a great deal to the art and science of the design of pre-stressed concrete. So this is T.Y. Lin. Actually, T.Y. Lin is again another famous name in pre-stressed concrete design. Actually, T.Y. Lin has a book. He's an author of a book about pre-stressed concrete design. Actually, I sometimes use that uh, book as reference. And his greatest contribution in the pre-stressing industry is that he formulated what we call load balancing method, which considerably simplified the design process, particularly in continuous structures like continuous beams. So later on, we will study what what is that load balancing method that T.Y. Lin formulated. So that's all for the historical development of pre-stressing. So we already accomplished our third goal. We are already familiar with the historical development of pre-stressing. Now we are down to our last goal for this meeting, which is to understand the basic concepts of pre-stressing. So without further ado, let's go to that to address that goal for this meeting.